Hi guys, today we're going to be talking about properties of solutions. This goes right along with your properties of solutions note sheet. So the first thing we need to talk about is what is solubility. So the solubility of a substance is the amount that dissolves in a given quantity of solvent at a given temperature. So typically the way that we see this is in grams of solute per solvent. But you're going to see later on in this presentation that it can also be two liquids. It could be a solid and a liquid that we're talking about. So think about like if you've ever made powdered lemonade mix, or if you've ever made like a Kool-Aid, your solute would be your Kool-Aid, and then your solvent would be water. All right, so there's a few factors, 4 of them that we're going to talk about that affect solubility. The main factors that affect solubility is the nature of the solute and solvent. Remember from our notes the other day, like dissolves like. So a polar solvent will dissolve in a polar solute. Nonpolar will dissolve in nonpolar. Agitation, which just means stirring of the solution. The more mixing that you do, the faster that it will dissolve. Temperature, typically a higher temperature, it's going to help to dissolve that faster. Think about like iced tea versus hot tea. It's going to be a lot easier to dissolve sugar into your hot tea than it is into your iced tea. And then particle size. If the particles are smaller, it's going to be easier to dissolve them because they have less surface area. If they're bigger, you're going to have to put a little bit more effort in, maybe a little bit more stirring to get them to dissolve. So there's 3 types of solutions that we're going to be talking about: saturated solutions, unsaturated solutions, and supersaturated solutions. So a saturated solution contains the maximum amount of solute for a given amount of solute at a constant temperature. So changing temperature, one of those factors that affects solubility, changes how much can actually dissolve. We'll get to that in a little bit. But a saturated solution, just think of it as being completely full, like Thanksgiving dinner, you can't even eat anymore. Unsaturated means it contains less solute than a saturated solution. So it has the ability to dissolve more solute. So if you had your cup of tea and you're dissolving sugar in it, an unsaturated solution, it would keep on dissolving. For supersaturated solutions, a solution has more solute dissolved than it theoretically should. And the way that you get this to happen is by changing temperature. This is how they make like rock candy or anything that forms crystals. If you think back to what we did around winter break, we made those borax ornaments and those crystals formed overnight. That was a supersaturated solution that we made. So just a little bit more of an example: an unsaturated solution, you're able to dissolve more solute. A supersaturated solution, you're going to have crystals growing. And a saturated solution, no more solute dissolves. All right, so you already know that temperature affects solubility. Like we said before, it's easier to get something to dissolve in something that's a little bit warmer than a little bit colder. And I'm sure this is something that you've seen with either coffee or tea, or if you try to make lemonade in the summer or anything like that. When we talk about solutions, they have different concentrations. The concentration of a solution is a measure of how much of a solute that is dissolved in a quantity of solvent. A very dilute solution would not have a lot of solute in the solvent. A very concentrated solution would have a high amount of solute in the solvent. So if you go back to the Kool-Aid that we were talking about before, just a little bit of Kool-Aid and a lot of water would be a very dilute solution. A whole lot of Kool-Aid and just a little bit of water would be a very concentrated solution. All right, so here's just a practice problem to figure out concentration of sugar in this drink. So if you look over here at our serving size and everything like that, we have a serving size is 8 ounces, and there's 2 servings in this container. And when we look over here for our sugar, we have 29 grams per serving, because it says amount per serving, 29 grams. And we have our conversion factor here, just because we want to make sure we're using the right units. To figure out concentration, we want the amount of solute over our total volume of drink times 100 to get our percent. So we have for this bottom thing to go away. 8 ounces per serving, but we have 2 servings, so it's 16 ounces total. And 16 ounces, I'm going to use my conversion factor of 28.3495 grams to get a total drink amount in grams of 453.592 grams. Then I'm going to plug into my formula. So I have 58 grams of sugar, because remember, 2 servings, so I want to double the 29, divided by my total drink, 453.592 times 100, and I get 13 grams of sugar, or 13% sugar in this drink. All right. Ooh, say hi to Huey. All right. If both the solute and solvent, Hugh, come here. If both the solute and solvent are liquid, if both the solute and solvent are liquids, it's just called percent solution, and it's fine. You would handle it the same exact way. This is something that you would see maybe on hair dyes, or anytime you might use like those Mio things where you squeeze into your water like the drinks. That would be considered percent solution, percent by volume. So just a couple of formulas to be aware of, and the only real difference between these are the units that you have to be careful of. So for the volume of solute over volume of solution times 100. If you have a solute in grams and volume of solution in milliliters, that's fine too. Just be aware of your units. In general, the formula is solute over your total solution amount times 100. So you just have to be careful on sometimes the way the questions are worded. So our first one I have up here for you. It's also on your sheet. If you click through to the next slide, you're going to see me work out the problem as well. So our formula, solute over our total solution times 100 is what we're going to be using. So when we go to plug it in, we have 85 milliliters of ethanol over our diluted solution, which has a total volume of 250 milliliters. And we're going to multiply that by 100. We go to plug it in our calculators. Do 85 divided by 250 first, then hit your equal sign, then we'll multiply by 100, and we get 34% ethanol. All right, feel free to replay that if you would like. Our second problem, we have our 10 milliliters of acetone in our total solution volume of 200 milliliters, and let's work it out. All right, for example 2, we have 10 milliliters of pure acetone is diluted with water to a total solution volume of 200 milliliters. What is the percent by volume of acetone in the solution? So our solute in this case is the 10 milliliters of acetone because it's getting dissolved. Our total solution comes to 200 milliliters. So we're going to use solute over the total solution times 100 for our formula. When we go to plug it in, we have those 10 milliliters of acetone up top over our 200 milliliters of total solution, and we're multiplying that by 100 to put it in our percent. So we have 10 divided by 200, hit equals, then multiply by 100, so we get 5% acetone. Awesome. Feel free to replay that if you need to. Our next one is a little bit different. We have calculate the grams of solute required to make 250 milliliters of 0.1% magnesium sulfate. All right, so example 3 is a little bit different. So this time it says to calculate the grams of solute required to make 250 milliliters of 0.1 magnesium sulfate solution. So this time they're giving us the total solution, but they're giving us the percent. Our formula that we use is going to be the same, our solute over total solution times 100, but they already gave us the answer to this, and we're actually solving for the solute this time. So when we go to plug it in, we can just use X for our solute, because that's what we're going to be solving for. our total solution is 250 milliliters, and this times 100 is still there, is equal to our 0.10%. So our first thing that we want to do is get rid of that percent. We're going to do that by dividing both sides by 100. So we have 0.1 divided by 100. So we get 0.001 when we do that. And then we have x over 250 is equal to 0.001. We don't want to leave that 250 down there, and we're solving for x. So we're going to multiply out by 250 to get it to cancel on that side. Multiply by 250 to get it to cancel on that side. We multiply 0.001 by 250. X equals 0.25 grams of our magnesium sulfate. And then our last example is a mass volume example. We're going to treat it the same way. We have the 2.7 grams of copper 2 sulfate and 75 milliliters of solution. And let's work it out. All right, for our last example, we have a solution containing 2.7 grams of copper 2 sulfate and 75 milliliters of solution. And we want to know the percent mass volume of the solution. So we have our solute, the copper 2 sulfate. We have our total solution. Our formula, solute solution, 100. So when we go to plug it in, 2.7 grams of that copper 2 sulfate over,
I don't know what you want. You got potties?
75 milliliters of our total
You got
solution.
potties?
We're going to multiply that by 100. When we go to plug it into our calculator, 2.7 divided by 75, hit the equal sign, then multiply by 100, and we get 3.6% of that copper 2 sulfate. And that's it. Your note sheet should be done at this point. I hope that you got it all done. Feel free to go back and watch any of the other problems that you need to.